Good morning, everyone. Today is Monday, May 10th, and we are going to be starting on Unit 7-8, page 4, which should say Probability Review. As always, mine looks a little bit different because I have the key version I'm going to be putting my answers on. But anyway, our objective is to determine the probability of an event. So this is kind of a new topic that we haven't covered so far. But we do have our DIN question, which is a review from last week. Find the mode and the range of the set below. So you guys can go ahead and pause the video here, try that review question and the preview as well if you'd like. All right, hopefully you paused your video and tried those questions out for me. When I am finding the mode of a set, we just have to look for which number is repeated the most amount of times. Okay, so it's not the greatest number, which would be 10. It's actually which one we see the most amount of times, which actually looks like it should be 8. So in blue, I'm just going to underline mode here. I'm going to kind of show my 3 8s, and that will be my answer. In green, I'm going to do the range of this set, and the range does include the greatest number, and then also the smallest number, because we have to find the difference of those 10 minus 1 to get our range, which should be 9. Then we're going to go ahead and move on to this preview question. What is the probability of a coin landing on tails after it is flipped? I know we haven't quite talked about probability, and you guys are going to see a lot of different definitions and vocabulary that we actually need to go through first. But for this preview question, let's think a little bit closer. If I flip a coin, how many sides could it land on? There's only 2 sides, right? So we have 2 different outcomes that could happen. It could land on tails or it could land on heads, but they're only asking for tails. And so that's actually kind of a 50-50 split, 50%. Or if we're representing that as a fraction, it would be 1/2. Okay, I'm just going to write down that 50% as well. We will see that you can write percents in different ways, or sorry, write probabilities in different ways using those percents versus fraction form. Okay, let's go ahead and fill in some notes. I did say a couple of words while I was completing that preview question that may be new to you. And the first thing is probability. What actually is probability? And so I'm going to fill these in. We use probability to quantify, to get a number for how likely something is to happen, or the chance that something will happen. Okay, we're putting a number behind that chance. We don't just want to say, oh, yeah, it'll probably land on tails. We want to do the math and figure out how often or how likely it is to land on tails. Okay. Vocabulary for some different keywords here is outcome. And an outcome is one possibility of what could happen. So for example, when we talked about the coin, there's only 2 options. It could land on heads or it could land on tails. Only 2 outcomes that are possible, okay? And that would actually be called our sample space. All of the equally likely outcomes are included in what's called a sample space. So the sample space has heads and tails. We only wanted one of those outcomes to happen. And the event was actually that statement, the statement that describes one or more outcomes that you actually want to happen. Okay, so outcomes are all the different possibilities from that sample space, but the event is only the ones that you want to happen. Okay, it won't be all of them. Otherwise, we wouldn't really need probability. And then we have our actual kind of formula, or how we're going to be finding probability in fraction form. And what you want to do is have your numerator, the top number, be the number of outcomes from the sample that are part of the event. Okay, we can only put the numerator as the number of outcomes that we want. Any outcomes that are part of the statement or the event that we want to happen. And then the bottom is just the total outcomes. Okay, just like we did up here for our coins, we only wanted one outcome to happen that was in the event, this description, coin landing on tails. But the sample space included two different outcomes, two different possibilities. And so that created our fraction for us. Let's go ahead and practice this a little bit. Exercise 1 has a board game that contains a spinner that is divided into 10 equally sized sections as it's shown below. If the needle is spun just once, find the following probabilities as fractions. Okay, so there are a lot of different things happening in this sentence. First, they say equally sized sections. That's really important because now we know all of these are equally as possible. Okay, 10's not really, really big, which makes it more likely than, I don't know, 2, right? They're all equally likely. They're all in the sample space of equally likely outcomes. So our sample space is made up of 1, 2, 3, 4, 5, all the way to 10. There's 10 different options in that sample space, okay? 10 different outcomes in that sample space. But we actually need to figure out what outcomes are in each of these events. And then we use that to find our probability, okay? So what I'm gonna do here, I'm just gonna describe that sample space that I was just talking about, just so you guys kind of have that extra note if you need it. The sample space, this spinner, or why this is underlined, let me change that. Includes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, not 20. Okay. And what we're going to do is find how many outcomes are in each event. And then we're going to make that fraction using both of those numbers. And that'll be our probability. Okay, so sample space for the spinner, there are 10 different outcomes. So I'm going to write 10 total. But how many of those outcomes would make it possible to be a number less than 5? How many of those outcomes are less than 5? And we can see 1 is less than 5, 2 is less than 5, 3 is less than 5, and 4 is less than 5. I can list all of those if I would like. I don't really have to, but those are all of the outcomes that are in the actual event, which means there are 4 total outcomes. And now our probability is those 4 outcomes from the event over the 10 total outcomes from the sample space. Okay. We're going to do the same thing for our next question here. The event that they are looking for is that it lands on a multiple of 3. So which numbers are multiples of 3? 3 is a multiple of 3 because you can say 3 times 1 equals 3. 6 is a multiple of 3 because 3 times 2 equals 6. And then 9 is a multiple of 3. 3 times 3 equals 9. So that means there are 3 outcomes that are in the event. It's going to be our number on top. 10 total outcomes in the sample space, and now we have our probability. Very last event here, they want it to land on a number greater than 10. We actually can see that's not possible. There are 0 outcomes that match that event. So we're going to say 0 out of 10. Okay. Not all probability questions are about spinners. Some could be about dice or the likelihood of drawing a 10 out of the deck of cards, things like that. Flipping a coin again, or different situations like exercise 2. Okay, this time they're giving us a chart here. It looks a little bit complicated, but we're going to explain how it's working. And we can read our question first. A local pet shelter has cats and dogs in it, some of which have gotten vaccinated and some have not. One single animal is picked from the shelter at random, meaning all the pets are equally likely to be chosen. So again, that equally likely part is really important because that's telling us our sample space could include all of the animals. Okay, one's not more likely than another, they're equally likely. And then we can figure out what each event is to find that numerator for our probability. Okay. They do say express each as a fraction, decimal, and percent. We'll go ahead and do that once we have our first answer, right? Once we have that fraction. And we can take a closer look at this table and kind of see how they split things up a little bit, okay? If you wanted the cats only, you'd be looking at this row. 18 cats are vaccinated, 6 cats are not vaccinated, and there are 24 total. If you were looking at dogs only, you want to look at this row. 12 vaccinated, 4 not vaccinated, 12 total. If you don't care what animal it is, you just want to see how many are vaccinated, then you look at this column. 18 cats are vaccinated, 12 dogs are vaccinated, 30 total animals, you don't care what they are vaccinated. Or if you want just the animals that are not vaccinated, you're going to look at this column. Okay? Again, 6 cats not vaccinated, 4 dogs not vaccinated, which makes 10 total animals that are not vaccinated. And then the very last corner here tells you the total out of every single option. There are 40 total options if you're talking about all of the animals. Okay, so let's go ahead and take a look at this. We want the probability that the animal is vaccinated. So for this sample space, they are talking about all total animals, okay? Our sample space total on the bottom of our fraction has to be 40. They're talking about all animals. And then we want the probability that the animal is vaccinated. So we're looking in that vaccinated column. There are 30 vaccinated animals. That is how many outcomes are in the event, which is our numerator of this probability. Okay. When I'm changing this to a decimal, it would be about 0.75. And if I was changing it to a percent, it would be 75%. Okay. Then we need the probability that the animal is a cat. Okay, so again, they're using the sample space of all animals. And then they only want the cats. There are 24 total cats. Put 24 on top. I'm actually going to use my calculator to figure out this decimal. 24 divided by 40 is 0.6. which would make it 60%. Now we just have one last probability to find. The probability that the animal is a cat that has not been vaccinated. Okay, so this is where it gets a little bit more specific. They're still using the sample space of all animals. Okay, they didn't specify that they're only looking at the cat group and then finding how many are vaccinated. Okay. Otherwise, this would be written differently. It would say probability that the cat has not been vaccinated. So we would use sample space of 24 and 6 on top. Okay. But this is still saying probability of all of the animals. So we have 40 on the bottom. And now we're just looking for cats that are not vaccinated, which is 6. Okay, so let me explain that one last time. We really want to be careful when we're reading events, because if they had said the probability that a cat is not vaccinated, our sample space would have only included the total cats. It would have been 6 out of 24. But they said the probability that the animal, which means they're including all animals, and then we're looking for both cat and not vaccinated. So we matched that row to the column and found 6. Okay. 6 out of 40, let me use my calculator again. 6 divided by 40 is 0.15, which would be about 15%. Okay, that's just a little bit of review on decimals, fractions, percents again, because they could ask you for any of those 3. You want to make sure you're always following those instructions. All righty. The last exercise we want to do is actually comparing 2 different situations. So this is going to take us back to why we actually need probability. Okay. It says the final round on a game show allows a contestant to choose 2 options. They can pick one of 3 doors where only one has the $1,000 behind it, or they can spin a needle to see that if it will land on $1,000, so that they can win that money. And it's asking which one would you choose and why? And this is why we would want to use probability. How likely is it that you'll win on this game versus winning this game? Okay. For the doors, only one outcome has the money that you want out of 3 total outcomes. Okay. That is 0.33333 repeating. Okay. Or about 33.3 repeating percent. Okay. But for our spinner, our sample space is no longer 3. Now our sample space has 1, 2, 3, 4, 5, 6, 7 total outcomes, and only 2 of them have the money. 2 out of 7. So when I divide this, I'm going to find my new decimal. 2 divided by 7, that's 0.2857. We don't have to use the whole thing. We can round up 0.29. And you can see 29% is less of a chance of winning than 33%. Okay, so you would want to choose the doors instead. You have more of a chance of winning than if you chose to use the spinner to win the game. Okay. I want you guys to go ahead and work on some of these practice questions. Okay. Really, really think about the sample space, how many different options are there, and then the event. Okay, so we're listing all of the outcomes that could fall into the event. That number goes on top of our fraction, but all of the possible outcomes goes on the bottom of our fraction at sample space. And this situation is talking about dice. We have a chart here talking about apples and pears that are bruised and not bruised, or dented, like fruit can be sometimes. Okay. And then we have a last question about some students in my class versus Miss Marin's class. We're going to find two different probabilities again and figure out which one is more likely. We have a space for any other examples that you guys can think of. Okay, as you can see, we could really find the probability of a lot of different situations, including the exit ticket, which is if one letter was chosen at random from the word Mississippi. Oh, this is spelled wrong. That means it's actually printed wrong on all of our printed packets. That's my fault. But what probability do we have of the letter being an S if we choose randomly from that word? So lots of different situations, lots of different practice questions. Then you can complete your self-reflection, choose one activity from the activity choice board on Canvas, and then we are done for today. Bye, guys.